This video, we are going to convert decimals to fractions. So if we have a terminating decimal like this first example, we are going to just read its place values and write that as a fractional form and then write it in lowest terms. So this is 4/10, and we read it in place values. Both of those are even numbers, so I'm going to divide by 2. It's 2/5. These are like problems from 5.3, they're going to be numbers 41 through 55 odd. So that's my first example there. The next one is 575 thousandths. So we're going to divide the top by 5. 115 over 200, and it's still divisible by 5. So that's going to be 23 over 40. There we go. Next one is 265 over 1,000. And that's going to be 53 over 200. Dividing both of those by 5. And we have this one's a little harder because it's got a 0 in there, but this is 561 over 10,000. And this is going to be a bunch of 2s and 5s. This is not divisible by 2 or 5, so it can't be reduced anymore. Now we're going to get into some repeating decimals. So I will clear this. I need some space to do a little work here. So our first example has just 1-digit repeating. So it's going to be like that. And what we're going to do is we're going to set this equal to a variable that I'm going to call n. I'm going to multiply each side by 10 because we have 1-digit repeating, so I'm multiplying it by 10 to the first. So I'm going to call this 4, 4, 4, repeating, so on, like that, right? So I'm going to subtract the original equation up here from this equation. Subtract n from this side, subtract 0.444 repeating from this side. And when I do that, I get 9n equals 4. There's just a whole bunch of zeros over there on the right. Divide both sides by 9. And I get that n is equal to 4/9. And try another one here. .3 repeating. So I'm going to say that n is equal to 0.333 and so on, and 10n is equal to 3.333 repeating. Subtract n, subtract 0.333 repeating. 9n is equal to 3. Divide both sides by 9. N is equal to, and when we reduce this fraction, it's 1/3. So that means 0.3 repeating is equal to 1/3. Now this one's a little more challenging because there's some other digits that are not part of what's repeating. This is 1.72. So and sorry, this is 1 point, and then the 7.2 is repeating like that. So I'm going to need to get all of this group over to the other side. So this is going to be my n, but I'm going to multiply by 100 to shift it 2 places to get that entire group. This is going to be 172.727272. And then I'm going to subtract my original 1.727272. And that's going to give me 99. N is equal to 171. Then n is equal to 171 divided by 99. And they're both divisible by 9. So n is equal to 19/11. Let's try that on this next problem as well. 5.09 repeating. So now there's some space before it starts repeating. So I'm going to have to work on that. So this is going to be let's get this times 100 to move it over there. So this is n equals, let's make 100n equals 509.999 repeating. And let's subtract 10n, and that is going to be 50.999. My goal is to always get all these nines to line up with each other so that they zero each other out. It's going to give me 90n is equal to 459. So n is equal to 459 over 90. And these are both divisible by 9. So this is going to be 51 over 10. I know that that doesn't seem right because that would be the same as 5.1, right? But I promise you that 9 repeating is going to be the same thing as having a 1 in the next place value. So this is correct. It's 51 over 10. It's a very strange thing mathematically, but we could prove that. And since this was our last problem here, I'm going to just go ahead and show that to you. Since that's probably one of the more interesting problems that you could come up with, and you probably want to see some evidence of that. This is, we're going to use our same technique here. We're going to call that n. Going to multiply by 10. We're going to subtract n from both sides. And we get 9n equals 9. and n equals 1, which means that 0.9 repeating is identically equal to 1. And there's a couple other ways that we could show that with more advanced mathematical techniques, but they all come out to say the same thing, that 0.9 repeating is equal to 1. So if you see something, again, like this last problem that ends with a 9 repeating, that's the same thing as that, where you carry a 1 to the next place, and that is going to be 51 tenths. All right. We'll come back next time and talk about adding and subtracting fractions. And I'll see you for that next video.